Hi, Mr. Green here. I'm going to take you through another section of the energy topic of the AQA Physics GCSE. This is on thermal and nuclear power stations, and your learning objective is to know how electricity is generated in power stations. Please pause the video whilst you write that down as your learning objective. Okay, we'll start as we always do with some retrieval practice. If you pause the video and attempt those 5 questions. Okay, so question 1, what's the unit of energy? It's in joules. Question 2, what are the 3 types of fossil fuel? Coal, oil and natural gas. Why are they called fossil fuels? Because they're made from the remains of plants and animals that died millions of years ago. They failed to decay properly, so they held that energy within them. What's the equation for gravitational potential energy? Gravitational potential energy is mass times gravitational field strength times change in height. And what's meant by the efficiency of the machine? The percentage of the energy supplied that the machine usefully transfers. It can be given as a decimal or it can be given as a percentage. Okay, so our learning outcomes today are to know the stages of electricity generation in a power station and to compare fossil fuel power stations and nuclear power stations. Okay, so a quick starter question for us all. So, why does a plant photosynthesize? And why are televisions not powered by gas fires? Pause the video whilst you attempt that question. Okay, so answers for this one. In each case above, we change the energy store to one that is more useful to us. So with the plant, it transfers solar energy from the sun into chemical energy. That means the cells of the plant can then use that energy. They cannot directly use energy from the sun, but they can transfer it into a form that is useful. With the television, we transfer the thermal energy of fuel into electricity, and that's much easier to transport and much easier for the television to use. Transferring energy into a useful form is what power stations do. Power stations generate electricity, and electricity is really useful to us. We can transfer it long distances and it can be changed into any other type of energy using machines. But how do power stations do this? What are the details of how they do it? There are 7 parts to the power station that we need to look at. 7 of them are detailed there. First off, providing the fuel. At the start of the power station, the fuel is supplied to the power station. In fossil fuel power stations, this will be coal, oil or natural gas. Power stations are generally built near really good transportation links, so the fuel can be easily transported there from where it's mined or where it's gained in the first place. Second part is the water. Water is pumped through pipes into the boiler of the power station. The thermal energy that's produced from burning the fuel will transfer to the water and turn it into steam. The fuel is burnt in the boiler, and that releases thermal energy. The water that we've seen previously flows through pipes in the boiler. The thermal energy produced from burning that fuel transfers into the water, turning the water into steam. The steam then flows out through pipes out of the boiler, and it flows from there to the turbines. So the steam at number 4 is then produced in the boiler, it's then passed through a turbine. The moving steam causes the turbine to spin. Turbines are like large fans. If you get a windmill or a little windmill in front of you and you blow it, that causes the fan to move around. And it's the same case here. As the steam passes through the turbine, it catches on those fins and causes them to spin around. Turbines are then connected to a generator. The spinning turbines cause the generator to spin, and this is what generates the electricity. So linking the turbine to the generator causes electricity to be made by the spinning generator. It's then passed to a transformer. The current generated is passed to a step-up transformer. This increases the voltage of the electricity before it's distributed across the country, and this helps reduce energy loss. Okay, so 4 quick questions there on your progress check. Please pause the video and attempt those 4 questions. Okay, so question 1, why is electricity useful to us? It's useful because it can be transferred into lots of different energy stores really easily. We've got lots of machines that can transfer it from one form to another. Why are power stations built near good transport links? It's because fuels such as coal, oil and gas can be easily delivered there. What's the order of processes at the power station to generate electricity? It goes from the fuel to the boiler, boiler to the turbine, turbine to the generator, generator to the step-up transformer. What does the step-up transformer do and why is this beneficial? The step-up transformer increases the voltage of the electricity, and this is beneficial because it reduces energy loss when the electricity is being transferred across the country. Let's look at some parts in a little bit more detail. So the turbines, you can see some pictures of turbines there. The steam turbines in power stations are huge. This is so they can transfer large amounts of energy and we can use steam to spin them really, really quickly. By linking them to generators, this electricity can be easily generated. But how does this cause it to happen? What does the generator do? Top left there shows us a really, really simple generator. It consists of a magnet surrounded by coils of wire. Now when the magnet spins, it causes the electrons in the wire to flow. They are attracted and repelled by the north and south pole of the magnet. Now if we can make electrons move, if we can make electrons flow, that's an electric current. Connecting the magnet to the turbine when it is spinning, because the turbine's spinning because steam's flowing through it, causes the magnet to constantly spin. If the magnet's constantly spinning, we're constantly making electrons flow and move, and that's constantly generating an electric current. That bottom image shows a generator in a power station. This is much bigger and much more complicated than the simple generator we can see at the top, but it works on exactly the same principle. It basically causes a magnet to spin, which moves electrons in the coil of wire. That flow of electrons causes an electric current. It's what an electric current is, a flow of electrons, and that can then be passed to the step-up transformer. Electricity generated at a power station is normally at around 22,000 volts. We then place it through a step-up transformer, and that increases the voltage to around 275,000 to 400,000 volts. This high voltage makes energy flow at a much lower current. This is really beneficial. If a high current flows through a wire, it causes the wire to heat up, and that thermal energy that's released from the wire is lost from the electricity, so we lose lots of heat. If we can make a low current, it causes the wires to heat up less, so we lose less energy when transferring. Okay, 6 quick questions there. Please pause the video and attempt those 6 questions. Okay, question 1. Why is steam passed over the turbines in a power station? It's to make the turbines spin. How does a generator produce electric current? Spinning magnet causes the electrons in a coil of wire placed around the magnet to flow. It causes them to move. An electric current is a flow of charge. Why is the turbine connected to the generator? Because that makes the magnet spin. When the turbine spins, the magnet inside the generator spins. What voltage is produced by the power station? Around 2,200 volts. What voltage do step-up transformers change this to? Anything from 275,000 to 400,000 volts. Why is it useful to increase the voltage? Because a high voltage gives us a low current, and with a low current, less energy is lost in the transmission wires as heat. Now, nuclear power stations work on the same basic principle as thermal power stations. Thermal energy is transferred to water, which turns into steam, which makes a turbine spin. This turns a generator, producing electric current. But in a nuclear power station, the fuel is very different, and it needs to be controlled very carefully to ensure the power station is safe. Nuclear power stations use uranium or plutonium as their fuel. The atoms of these elements are caused to split. This is caused by firing a slow-moving neutron at them, and we refer to this as nuclear fission. Splitting these atoms releases huge amounts of energy, which can then be used to heat water and turn it into steam. There's a picture of a nuclear power station. Have a look at it and tell me, how is it similar to a fossil fuel power station, and how is it different to a fossil fuel power station? Pause the video whilst you attempt that. Okay, the similarities. It generates steam, that steam turns a turbine, and that turbine then turns a generator. The difference is it contains a reactor rather than a boiler. It needs control rods to make sure it's safe, and it's housed in a containment structure, so it's held in there, so there's nothing can escape and get out from there. The reactor itself consists of a series of fuel rods. These rods absorb slow-moving neutrons, and it's these slow-moving neutrons which cause the atoms to split. It causes that fission. When fission occurs, that releases energy, which is transferred to water, turning it into steam. This causes a chain reaction. When one atom splits, it releases more neutrons, which can then cause more atoms to split, which then cause more neutrons and more atoms to split. Now, if that's uncontrolled, it can generate far too much energy. So we need a control system, and these control rods will help us out. The control rods are made of boron. When the energy released is getting too high, we can lower these boron rods into the reaction. That absorbs neutrons, which slows the fission down. It stops the splitting taking place and controls how much energy is released. Quick 5 questions on nuclear power then, if you could pause the video and answer those 5. Okay then, question 1. How are nuclear power stations similar to fossil fuel power stations? Both use thermal energy to turn water into steam and cause turbines, then generators to spin. How are nuclear power stations different to fossil fuel power stations? They use different fuels, and the nuclear power station contains a reactor rather than a boiler. What are the fuels used in nuclear power stations? Uranium and plutonium. What's fission? Fission is causing an atom to split, and this is done by absorbing a slow-moving neutron. When that atom splits, it releases huge amounts of energy, and that's what we can use to heat the water into steam. How's fission controlled in a nuclear power station? Boron rods can be inserted into the reactor, absorbing neutrons, slowing the rate of fission, and therefore the energy released. Okay, I hope this video was useful for you all. There are other videos available on nuclear fission and non-renewable and renewable energy resources. Please review them to get a more rounded knowledge of the topic. Again, hope it was useful. See you all soon. Goodbye.